So for the math talks, you try to do this without a calculator and without any scratch work. Right now, we are finding the product, what this product means. Okay, good. You even gave me the right definition. It's not just multiplication, it's the answer to the multiplication problem. It's what your product is. So think about this. When you think you know the answer to 9 times 11, you put your thumb up. You don't say it, just put your thumb up. You think you know that one. Okay, Grace, what'd you get? And how did you get that? Okay, so just memorization on that one is what I think you mean. Anyone else do it differently at all? Or that one's just entirely memorization, no one did anything else? Okay, so now let me reveal the next one to you. 19 times 21, find it mentally, meaning without a calculator, no cheating. When you think you know the answer to 19 times 21, this is how. Okay. Riley, what'd you get? Oh, anyone get something different? Dude?
399.
All right, anyone get something different than those? Okay, so again, you weren't supposed to use a calculator. I did because I don't have that memorized. There is a way that I could probably do it in my head, but it is $3.99 for the right answer. So Jude, how did you get that without a calculator? And what did it look like in your head so that I could write it on the screen? Okay, so that you would do by timesing 1 by 19, right? You did that first. And then you have like a 0 placeholder, that's like the rule when you go to the next place value. 2 times 9 is, there's 1, 2 times 1 is 2, plus the 1 that you carried is 3, added together. So Jude says he did that in his head. Did anyone else get $3.99 but do it differently in your head? If I were to, I don't know, break up the numbers in any sort of way, like, do you think maybe timesing by 20 would be easier? Anyone think of it that way? Did anyone think of it as timesing by 20 and then adding 19? That could be another strategy. So just giving you things that you can use on the next two that I reveal, but maybe 19 times 20 or even, I don't know if 19 times 20 works, but 19 times 20 might even be easier because it ends in a 0. So you kind of just can leave it there and then continue. Or I guess I'm still missing this 19 because it's plus another amount of it. And that's another way to get the $3.99. Make it into more manageable numbers that you can multiply better in your head. Just a suggestion, you don't have to do that. But now this one, 99 times 101. Is there a way you can do that without a calculator in your head? That's easy. If you think you know the answer, put your thumb up. Those sums, see if you have it. All right, Micah, what'd you get? And how were you able to do that without a calculator? Okay, good. Because multiplication is repeated addition, so if you make it something more manageable, like times by 100 is more manageable because you just add the two zeros. Then if you add the 99, because timesing it by 101 is basically 900 plus itself 101 times, that is how you can get the correct answer. Let me put that under going to the space. But yes, that is correct. 9,999. Last one for the math talk. 109 times 101. You think you know it? Put your thumb up. You think you know it, Aiden? I'm feeling. Just try to think about it. If you can show me your thumb up and get the right answer, then I'll let you go. And then you can get the explanation. So looking for those sums, 109 times 101 without a calculator. Can you, was that exceeded by the sum? Oh. Grace, what'd you get? Okay, anyone else get something different? Okay, I see some people trying. I appreciate it. I would normally give you more time to try, but in the real world, you could use calculators, but for this exercise, we're trying not to use calculators or scratch work. So Grace, can you tell me how you were able to find that one real fast? Because you are right, it is 11,009. So how were you able to get that? Okay, so 100 times 109, so basically breaking this up into like 100 plus 1, basically. So 100 times 109, we know that when we multiply by 100, we basically are adding two zeros. But we still have to add like another unit of this, because we're actually multiplying by 101. So then we add 109 to that. And that gets us, sorry, I need it to be like, on top of the other, like, see it better. That gets us to here. I don't know if she added it this way in her head, but it does get us 11,009. That is the right answer. So good. Again, would I ever make you multiply those without a calculator in this class? Only for math class. It's the only time you do that. Helps you get a little more fluid in your math. So today we are doing lesson 8, which is the last of 3 parts for the rewriting quadratics in factor form. I'll show you the objectives real quick. Jamie, you can go now. Also, let me just get that. I already told you guys. Okay. So the goal for lesson 8 is to look closely at some special kinds of factors. So explain why multiplying a sum and a difference results in a quadratic expression with no linear term. You guys know what they mean by linear term? You guys know what they mean by linear terms? So we're dealing with quadratic expressions. We have how many terms in this standard form of our quadratics? We have 3 terms. So everyone sit up and look. You guys know how to tell the difference between terms, like when a term starts and ends? Terms are separated by plus and minus signs. And equal signs too, but we have 3 separate terms here. We have an x squared term, an x to the first power, and a constant. This is where your terms start and end. Which of these do you guys think is the linear term? Bx, good. X squared is quadratic, right? We learned that. You guys are pretty good at telling me that one. But whenever it's just x to the first power and nothing higher than that, that's our linear equation, like y equals mx plus b. All right, so when we say there's no linear term, that means that in this lesson, we're going to see what happens when we have expressions that are just ax squared plus b. So like x squared plus 4, or something to that effect. So we'll look at things like that today. And then also by the end of the lesson, you need to, when you're given something in standard form, rewrite it into factor form. We did that for the first time yesterday, using the diamond method and all of that good stuff. I record every day in case you didn't know that. It'll be linked in the slides always. So if you're ever absent, go there. Puzzle piece is lesson 8. You would expect your first quiz to be Friday. Remember, you guys were today is Thursday. So Friday will be your first quiz. Any questions on anything of this? First quiz for this unit, not your first quiz. So you need to make sure your notes are up to date, that you understand, that you're asking questions. Even if you have to email me, I do still check my email on days that I'm off. I might not respond right away, but I will respond to you before you take your quiz. Okay, so here's the first activity for today's lesson. Claire claims that the sum of 10 and 3 times the difference of 10 and 3 is equivalent to 10 squared minus 3 squared, and that the sum of 20 and 1 times the difference of 20 and 1 is equivalent to 20 squared minus 1 squared. Do you agree? Show your reasoning. So good practice for your constructive response type questions. If you finish that early, look at number 2. It says use your observations from the first question and evaluate the sum of 105 times the difference of 105 and show your reasoning. I'll give you 3 minutes to try number 1. Evil 6, what'd you get? Do you think that Claire is correct? Yeah. And what did you do to prove that? Oh, okay. So let's see. And there's other ways. I'll talk to you about your other ways. So foiling works for multiplying binomials, which is what these are. First, outer, inner, last. So multiplying the first term with 10 times 10. It is 100. I am going to write it as 10 squared though, just because we're trying to prove that this is equivalent. So I'm going to write it as 10 squared, even though it is 100. Multiply your outer term. What's 10 times negative 3? Inner terms, 3 times 10, 30. Positive 30, so put plus 30. And your last term in each parentheses, 3 times negative 30. And I'm just gonna, it is negative 9. I'm gonna write it like this. Although I'm not a huge fan of that because like, it is like negative 9, but we're trying to prove that she is correct. Or does someone think that that's incorrect? So look at what happens here. With the negative 30 plus 30, what does that equal? 0. So that's where she's getting that they are equivalent. Does anyone else agree that they're equivalent? And do it a different way? So what I did, or what I would think to do, since these are all numbers, there's no variables, I just simplified them and saw if it gave me the same amount. So like, what's 10 plus 3? What is 10 minus 3? 7. And then because you are allowed to use calculators now that it's not the math class, I would have done 13 times 7 is 91. Compare it to 10 squared minus 3 squared. What's 10 squared? 3 squared is, and if I subtract them, I also get 91. But I do like this way because it relates it back to quadratics, like from unit 6. Does that make sense? Any questions? So we're on the consensus that Claire is correct. Does it work for this one too? Did we check that one also? Okay, if not, let's check it right now. What's 20 plus 1? 20 minus 1? Multiplying together. 21 times 19 is 399. I think we did that in the warm up. 20 squared, what's that? What's 1 squared? And then if we keep that minus in the middle like that, it does give me 39. Okay. So questions, comments, concerns? So we're saying Claire is correct. So use your observations from the first question to evaluate this one. Also, what do these have in common? Because it's trying to get you to see something specific, but I'm not sure that that is like really clear to you guys. It's clear to me because I know what it's trying to do. What do these two expressions have in common? It could be really simple, what your observation is. So like, you could say they both have parentheses, right? Don't they both? Okay, so the second number in each parentheses is always like the same but opposite signs. Is the first number in each parentheses just exactly the same? So let's make a rule almost, and then I'll tell you what that rule is called. So say that the first number in each parentheses is a positive A. The second number is B. We have something in a setup like this. Right? So like the first number in each parentheses is exactly the same. The second one's the same but opposite sign. What we get when we do FOIL it out, so like first terms A squared, outer terms, negative AB, inner terms, positive AB, last term, negative B squared. What we get is something that cancels out what would normally be our linear term. Because normally we do like x plus 1 times x minus 2 or something like that. And what we end up with is this. A squared minus B squared. That is called the difference of squares rule. So can you guys like maybe write that down somewhere, start, highlight it? I think you even have space to write it. Am I right about that? Maybe on the back. Oh no, you just have it on the left. You see where it says difference of squares? Can you write this definition? So difference of squares. You're gonna write this, you can even show this part. But I'm also gonna include a squared minus b squared. Star it, highlight it, super important. Because you guys already know how to FOIL and multiply. That's something we learned in Unit 6. Now you're gonna go from things that look like a squared minus b squared, and you're going to factor them, write them in factor form according to this difference in square root. You stay in it, continue doing that. So what does difference mean in math? Good, doesn't mean subtraction. So if you notice that you have a difference of squares, so like perfect squares, like 100 is a perfect square, because when I square root it, I get 10, not like a decimal. 9 is a perfect square. When I square root it, I do not get a decimal. If you see a difference of squares, you know that your factor form is gonna look something like this. In parentheses, a plus b and a minus b, where a would be like the square root of a squared, b would be the square root of b squared. Okay, so apply that to the next couple of problems, to number 2 and 3, which are above it. And then answer number 4. So I know we're kind of working like on the random parts of the paper. But now knowing that fact, answer 2, 3, and 4. For number 2, you could have FOILed, or you could have just worked it out the way that I did. I'll leave that part up to you. 100 plus 5 is 105. 100 minus 5 is 95. Multiply that together. That's kind of like the same thing as what this is doing. You get 9,975. All right, but this is equivalent to if I just wrote it as 100 squared minus 5 squared. Kind of related to what we already saw already. This one's not really brand new information. We're going to keep going. All right, but number 3 on the front side. So it says, prove that these are equivalent with a diagram and without a diagram. I mentioned that you will see this on your final. So good practice for that. When it says with a diagram, it means like this area model or box method, whatever you want to call it. I know to set it up like this because the factor form is a 2-term times a 2-term. So with a diagram, it would look something like this. X and positive 4 on one side, X and negative 4 on the other. It doesn't really matter if you did the negative here and the positive there, as long as they're different. Is it about this? Okay, then wait. And each little square should be basically the area. That's why we call it an area model. What's X times X? What's X times 4? 4X. What's negative 4 times X? And negative 4 times 4. And then combine like terms, or you could, I guess, write it out and then combine like terms afterward. You combine all of the areas within your diagram. And what happens to the 4x plus negative 4x? So that is why it is equivalent to this, although they're writing negative 16 as 4 squared. 16 does equal 4 squared. So you could prove it this way. Now, without a diagram, you could FOIL. That's more up to you. You could FOIL. You could double distribute. You could talk about how this is a difference of squares and apply our difference of squares rule that we just learned. Which says that if I have two perfect squares and difference means that they're being subtracted, that I can factor it according to this rule. Where A and B are the square roots of A squared and B squared. So is this a subtraction problem? Yes. So it is a difference. Are these perfect squares on each side of the minus sign? Is x squared a perfect square? What times what gives me x squared? So it is a perfect square. What's the square root of x squared? X. And 4 squared is a perfect square. When I try to take the square root of it, the square will cancel. 16 is probably more what they'll actually write. What's the square root of 16? So if I write my answer according to this rule, it's x plus 4 times x minus 4. This is a difference of squares. Okay, questions on that? They didn't write down. You don't need anything on your number at all, so you don't have to go there. Okay, questions on that? Now, can I apply my difference of squares rule to this down here? What'd you guys say? Yes, no? So you're saying that these are equivalent to each other. Then if they are equivalent, I should be able to either FOIL, double distribute, make my box diagram. Don't forget that you can't just distribute this exponent. You have to remember that exponents tell you to multiply the base by itself. So you have to expand it first to x plus 4 times x plus 4. And now you can FOIL, double distribute, box method it. On one side of my diagram, it'd be x and 4, both positive. The other side, x and 4, feel like you're not paying attention. Are we writing this down? And then we're moving on to the back and you're trying all those ones on the back. Okay. So what's x times x? What's x and 4? 4. X and 4, 4 and 4. 4 times 4. So is this going to be equivalent to x squared plus 4 squared? What happens when I combine like terms? Do they? What do I get for my middle term? So this is not equivalent. You would say this is not equivalent to x squared plus 4 squared. Because 1, when you multiply it, you get a trinomial, not a binomial. And 2, this is not a difference of squares. I should not expect my factor form to look like the x plus 4, x minus 4. This is you adding squares. There's no special rule for that. This is not equivalent. Questions, comments, concerns? Okay. So on the back of your note sheet, and I see some people writing, so that's why I'm not flipping to it yet. But on the back of your note sheet, we've seen something similar to this before, except for now it's also including the difference of squares. You are going to, if you're given the factored form, provide the standard form. If we're given the standard form, provide the factored form. There is one that is impossible though, so like, don't spend all your time on one row. Says, heads up, one of them is impossible. But when you see that there's no linear term, check to see if it's a difference of squares. So is this a subtraction problem? So it is a difference. Are there perfect squares on each side of the minus sign? What's the square root of x squared? What's the square root of 81? So then my factor form will look like this, according to that difference in square root. So fill out what you can. I'll check in with you in about 3 minutes. I don't expect you to be done in 3 minutes. I'll just help you a little bit more. So before I only got through like one table earlier. So table 1, what is my standard form when the factored form is this for the first row? From unit 6, we should be able to do that one, no problem. You could FOIL, you could double distribute. You could recognize that it's something we talked about before. So table 1, that's the one you have. I'll come back to you. Table 2, what's my standard form for the second row? I know what you said. Close. What's 2x times 2x? But otherwise, good. And now, like, I know we were doing a proof on the first page, so we left it as 1 squared. What is 1 squared? So then also just erase this, and that'll be more what we expect. So again, you could FOIL, you could double distribute. I won't show you that again because we've already done that for a long time. What you also could have done is recognize. We have the same exact number for the first part of the parentheses, or the same exact terms. The second term in each parentheses is the same but opposite sign. So the standard form should look something like this, where there's no linear term, where it's this multiplied together, and then my last terms multiplied together. My inner terms and outer terms, I guess you could say, cancel. Question, does that make sense? Okay. Table 1, did you get the standard form for the first one? All right, we got 10 minutes to go over the full rest of the page. We cannot spend something this long on something from unit 6. What's the answer? Okay, let's FOIL then. Because I'm sorry, we have 10 minutes left. Let's go. First terms, multiply them together with x times x. Outer terms, multiply them together with x times 10. Inner terms, multiplying with -10 times x. Last term, multiplying with -10 times 10. And I actually need to move this all over to the have room. But what happens with my linear terms? So then really it just becomes x squared minus 100. So table 1, get your lives together. You're now responsible for the third row. Please do not take that long when I come back to you. Table 3s, all the way down to this row. What would be my factored form of 49 minus y squared? Good. that works. Could I switch it to 7 plus y being first? You can. This you should recognize is a difference of squares. It's a two-term expression with subtraction in the middle. Square root of 49 is 7. Square root of y squared is 1. Good, perfect. Table 4. What's going to be my standard form for this one? Good, let me just move this over. I'm anticipating I need more room. Okay, and then? Okay, perfect. Again, this is a difference of squares. We have subtraction and 2 perfect squares on either side. Square root of 9 is 3, square root of z squared is z. Square root of 16 is 4. Table 5. 14 plus 9 and then 14 minus 2. Okay, great. Again, difference of squares. Table 6. What about this next one? What would be my standard form for this one? Did you say 0.16? Do you know what the equivalent fraction would be? There's like a decimal to fraction button usually on your calculator. I'm gonna multiply them by hand. When we multiply by hand, what's 2 times -2? What's 5 times 5? So the minus is already there, just ignore it. 4 over 25 is 2/5 squared, times it by itself. Questions on that? And that should be equivalent to 0.16. Just have it as a fraction if they do that. Okay, questions on that one? Okay, table 1, back to you. What's the answer for the third row? Okay, do you guys agree with that? What do you guys think it should be? Okay, x squared minus 16 or 4 squared. I would have left it as 16 minus, wait, does that even mean the same thing? So this, you could multiply them out if you want. It should be 16 minus x squared. Or negative x squared plus 16, is that what you guys said? Negative x squared plus 16, is that what you guys said? I can't remember, I can't go back in time, maybe when I watch the video later, I'll see exactly what you guys said. But it should be this or negative x squared plus 16. Those are the only 2 options. If you want the x squared to be first. So this has it with the first number exactly the same in each parentheses like it is in this rule. Second term, same but opposite sign. So you could apply this difference of squares rule, or you could FOIL it out, and we'll see that the 2 terms in the middle cancel out, the x term, and then your answer is just this. Okay, moving on. Table 2, what is my factor form of this one? Why don't you want to answer this one? Gonna say no. Is this a difference of squares? So it is a difference, but it is a minus, a subtraction problem. Are these perfect squares on each side? I can see we're struggling with the fraction. What's the square root of 49? What's the square root of 16? So it is a perfect square. I didn't mean to still leave this very simple here, but. The square root of 49 over 16 is 7/4. So now that you know that, can you put it together? Good, and I think they actually use the d, but same difference. The variable squared, the square root of it is that variable. Okay, you can use your calculator for that part, but I don't think I have time to show you that today. We're gonna continue, we're gonna finish this table. Table 3, what's the answer to this one? Okay, is this one a difference of squares? It's not. When I multiply it, I get a trinomial. That is the correct trinomial. So yes, so assume this one didn't have opposite signs. Table 4, is this one a difference of squares? What does difference mean in math? So it is a difference. Is x squared a perfect square? Is 6 a perfect square? So this one, we'll call it prime because it's not factorable. There's no GCF to factor out. There's no other way to factor it. But this one down here is actually the one that's impossible. This one is the impossible one. Prime and impossible is a bit different. This is not a difference of squares. This is an addition problem. So sorry you didn't have room for your, or time to do your practice. Some of these problems took a bit longer. But the practice that goes with this is less than 8.